good the second. At least I know how to spell that sentence properly without having to think for 30 seconds. Erica, there's the question that you missed. That's how the video starts. Here you go. Sorry, Erica. Let's do this one.
Math 30-1, 10 years from now, like what?
Yeah, who's Erica? When we're like doing those welcome back, Erica. Just a 25-minute break. Okay. This one says the equation f of x equals x minus 2 times x plus 3 is stretched vertically by a factor of 2. Okay. What does that mean? What's actually happening? What am I multiplying by 2? Yes. Multiply y values by 2. That is what that means, right? When you read stretched vertically by a factor of 2, that is exactly what's happening. Y values times 2. And horizontally by a factor of 3. Horizontal means what? X values, perfect. So I'm multiplying x values by 3. It's not 1 over 3. It is 3 because they use it in a sentence by a factor of 3. So in the equation, if I wanted to describe that same thing but in function notation, it would look like this. The 2 would be on the outside for my vertical stretch. And then my horizontal stretch would look like this. 1 over 3x.
Okay, so if it's 1 over 3 in the factor, though, it says...
Then when I put it in, it would be 3. Yes. It's the opposite of what it looks like.
And we put that on all of the x's.
Yeah, sorry, we just haven't read the rest of the question, but that's what we're going to do. So it says determine. So this is now what we're trying to do, right? Determine the new x and y intercepts. Okay. So I'm looking for the new x and y intercepts. I can get to those x and y intercepts by doing these things. Multiplying y values by 2, x values by 3. So if I want to find the new x and y intercepts, I first need to find the old x and y intercepts. And then finding the new ones wouldn't be so hard, right? I'm just going to multiply them. All right, let's start with x-intercepts. How could I find the old x-intercepts from this original function?
First, you just look at the brackets and whatever makes them equal 0, that's your x-intercept.
You got it. So when you're talking about x-intercepts, that means that y equals 0, which means you now have this equation. 0 equals x minus 2, x plus 3. Right? I took my function, I changed y, or f of x, to be 0, because that's what an x-intercept is. In Math 20-1, we call this a zero product property. So if I have two things multiplied together, and they have to equal 0, that means you're trying to figure out what makes each set of brackets equal 0. The first x-intercept would be at 2. Second x-intercept would be at negative 3. My old x-intercepts are 2, 0, negative 3, 0. That's my old x-intercept. How can I find my old y-intercept? You could change the form because that's factored form. So you could multiply together to general form, and it's the constant. That would work. I think there's an easier way. Yes, y-intercepts mean that the x value is 0. right? So go to your equation, change x to be 0, and then just calculate it. So I have y equals 0 minus 2, 0 plus 3. You throw that in your calculator, and your y-intercept is negative 6. 0 minus 2 is negative 2. 0 plus 3 is 3. Negative 2 times 3 is negative 6. My old y-intercept is 0, comma, negative 6. Those are the old ones. We're trying to determine the new ones. To determine the new ones, you multiply the y values by 2, multiply the x values by 3. And that'll give you your new x and y intercepts. Technically, those x-intercepts, multiplying the y values aren't going to do anything, right? Because the y is 0. But I am just going to show, like, I did multiply all my x values by 3. Like, everything did get stretched. And then I'm going to multiply all my y values by 2, even though it doesn't actually make a difference on some of them. I just want to show that I am doing that stretch, like both ways. So my new x-intercepts are at 6, 0, negative 9, 0, and my new y-intercept is at 0, negative 12. Stretching not that bad. Better than yesterday.
So does it really matter if it's a fraction when it's in the equation?
Mm-hmm. That's where people get so caught up, is like, when is it 3? When is it 1 over 3? Okay? This is the only time that it's not actually what you're multiplying by. When it's in the function notation, the horizontal stretch does not look like the actual number you multiplied by. When I talk about it, it changes to the proper number. When I actually do it, it changes to the proper number. But in function notation, my horizontal stretch is actually flipped.
So what is the transformed equation? Also.
What is the transformed equation? Hey, good call. But I used all my space. So what is my new equation? So my transformed equation looks like this. 2 f of 1/3, like I had over there on the other side. Right? That's my new equation. Okay, so to actually perform that, the 2 multiplies by all of f of x. So my 2 would be right here. I'm going to do this in 2 steps. Normally we do it in 1, but I just want to show you that I'm doing it in 2 steps. See how I put the 2 in front of f of x, like in front of the function? So I had x minus 2x plus 3, and then I multiplied that function by 2. So I put 2 in front of that function. No. No. Yeah.
So are you turning the 1 over 3?
I've not done anything with the 1 over 3 yet.
Okay, you're just showing
I'm just showing you how to put in this 2. That's all I'm doing right now. It just multiplies by the whole function. Better? Okay, now let's do the 1 over 3x. So this now goes in for x. Right? Because you're taking your x values and they're becoming 1 over 3x. And it actually is 1 over 3x. It's not 3x. So it would look like this now. Y equals, I'm not going to have enough space. Y equals my 2 out front from my vertical stretch. And then my x's change to 1 over 3x. Like this. And now you can see my horizontal stretches in there. That would be your new equation. Y equals 2, 1/3 x minus 2, 1/3 x plus 3. Cool. Let's do another one. Oh, look, asymptotes are back. So it said, the graph of each log function listed below, where b is greater than 1, has a vertical asymptote. The number of functions listed above that have an asymptote of x equals 0 is. Okay, let's talk about just our basic log function. Again, the proper term would be like the mother function. This is just like your regular log function. What would it look like? So y equals log of x. It looks like this. Goes up and curves. That is your regular log function.
If it's negative, does it go the other way?
If it's negative, it does flip it, yeah.
Okay.
That's my regular log function. Where's my asymptote on my regular log function? X equals 0, which is the y-intercept. That is x equals 0. Yes, sir. Yep. Okay, now if you look, they took that basic log function and they did a whole bunch of different things to it. Okay, there's your basic one. Then they put a 2 in front, then they put a 2 inside, then they added 2, then they added 2 on the inside. They did all different kinds of things. Okay, we're going to try to figure out which ones would leave the asymptote at x equals 0. Fair? Do we see our goal of what we're trying to do? All right, looking at the first one, that's just our regular mother function. That thing does have an asymptote at x equals 0. That's going to work. There's nothing that's been done to it. Looking at the second one.
Wait, so having the b doesn't change anything?
No, the base can be anything. It's still going to be that same function. Look at that second function. They have now taken the function log b of x and they've multiplied it by 2. What they've done is they've taken their function and multiplied it by 2. Right? This is a vertical stretch. So if you had an asymptote on your y-axis and you stretched it vertically, would that move it? No, it would still be right on the y-axis. Like taking a asymptote and stretching it vertically would do nothing. And I don't know if it get longer. It's already infinitely long, right? So what's doubling something that's infinitely long? It's still infinitely long, right? So that thing did not move. It is still going to be x equals 0. Gorgeous. Third one. They took x and they changed it to 2x. That means they've done this. Y equals the function of 2x. This 2 is a horizontal stretch of 1/2. Right? If you actually multiply it, you're multiplying horizontally by 1/2. So imagine our asymptote over here. That is at x equals 0. So if I stretched it times 1/2, would it move? No, x equals 0. 0 times 1/2 is 0. This would not move. Okay, it's already on the y-axis. It can't stretch away from it if it's already on it. So that would not move. It is still x equals 0. That one is good. Fourth one. They took the function, log b of x, then they added 2 outside of the function. They have done this. Y equals f of x, and then they added 2 to the end of it. What would that plus 2 be? What transformation? Yeah, up 2, right? This value moves things up or down. So would your asymptote move or change? If it was at x equals 0, and I took that entire asymptote and I shifted it 2 up, still in the same spot. It did not move. That means it is still x equals 0. Last one. No, not quite. It's log transformations, but like it's very basic transformations. Looking at this one, what they did was they took the function log of x and they changed x to be x plus 2. When they add something in here, it's moving it left or right. It's the opposite of what it looks. And so this is actually 2 to the left. So if you took your function and you moved everything 2 to the left, would the asymptote change? It was here, 2 to the left. It definitely changes. It's now at x equals negative 2. That thing does not have the same asymptote. There's 4 equations here that have the exact same asymptote of x equals 0. So it'd be C. I feel like I see like more nodding today, which is usually a good sign. It's like, yeah, I think I see what's happening. That's a good example of all 4 things we've learned. And we did both stretches, both translations there. Yep.
Would this third one not work if it wasn't on 0? If it was on like 1?
If it was on x equal 1, the third one would still be at x equals -1. So